Alright, let's consider what happens when we take a fraction raised to a power. Well, a fraction raised to a power, well, just any number in general raised to a power means we're going to be multiplying that number by itself multiple times. So we get z over 3 times z over 3 times z over 3. And I know when I'm multiplying fractions, I can just kind of squish these together. All the tops multiplied by each other, that's z cubed. And all the bottoms multiplied by each other, 3 times 3 times 3 is 27. In general, if I was to do a over b and raise it to the power of r, I would just get a bunch of this fraction multiplied a bunch of times. And up on the top part of each of these fractions, I would have an a. In fact, I would have r of them, so I'd get a to the r. And on the bottoms, I would also have a bunch of b's, so I'd get b to the r on the bottom. So this one is a very close analog to the distributive property that we saw before. If we had a product raised to a power, this one looked like a to the r, b to the r. Well, this one, these two go very nicely together. This is another distributive property. We're going to take that r and distribute it to both the numerator and the denominator of the fraction. So much so, in fact, that we actually use these properties together often. So in this case, I would think of this, let's think of this negative. I'm going to put this up on that 2 just so I can have it somewhere else instead of having it be its own thing out in front. I'm going to think of this as a -2, a y, and a z. So those are the 3 different parts of this. So when I take and I raise this to the third power, I'm going to get -2 cubed, y cubed, and z cubed. Well, -2 cubed, I can deal with that. That's -2 times -2 times -2. That's 3 negatives, so it's going to end up being negative, and specifically -8. And we get y squared or y cubed over z cubed. All right, the same kind of thing can go here. We have a 2, we have an a squared, and we have a b cubed. Those are the 3 different parts here. I'm going to take and distribute this forward to each of those. 2 to the 4th times a squared to the 4th times b cubed to the 4th. Now I'm writing it like this to help you remember how what law of exponents we should use here. Just a quick reminder, it looks like this: a to the r to the s is equal to a to the r times s. So this ends up being, well, 2 cubed. I need 2 to the 4th, rather. I need to do that first. That's 16. 2 times 4 is 8, so this would be a to the 8th. And 3 times 4 is 12, so we get over b to the 12th.